Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at solving without replacement probability questions using tree diagrams. So let's look at this question here. So let's say Mr. Luck has bag, 7 Mars bars, 3 boosts. We pick 3 chocolates from the bag, one after the other. What's the probability at least 2 of them are Mars bars? So we looked at this exact question in the previous video, but in that we did with replacement. We assumed each time a chocolate was picked, it was replaced by an identical chocolate. We're going to do this one without replacement. So we're going to find this probability assuming that each time I take a chocolate out of the bag, I don't replace it. So we're going to use a tree diagram like we did in the previous video. The only thing that will change is the probabilities after the first stage. So remember, we set up our tree diagram by having columns for each stage. So here, this event occurs in 3 stages, each stage being a pick from the bag. So we write our possible outcomes. So first time, we could get Mars bar or boost. Similarly, Mars bar or boost for the second time, and so on. And then remember, we had a column in which we write all of the possible outcomes. So for this one, because each time I pick a chocolate, there are 2 possible outcomes, 3 stages. Total number of outcomes is 2 times 2 times 2 to the power of 3, which is 8. So this tree diagram looks very similar to the one last lesson. In fact, so far, it's exactly the same. Now remember, each of these outcomes is not equally likely to occur. So we can't just say, this has probability 1/8, 1/8, 1/8, because, of course, we're more likely to get a Mars bar. So we're going to write on the branches each of the probabilities. So 7/10 that I get a Mars bar first go, and 3/10 that I get a boost. Exactly the same as what it looked like when we were doing the question with replacement. Now this is where the difference starts. So if it's without replacement, the probability I get a Mars bar the second go, if I got a Mars bar the first go, is different. If I get a Mars bar the first go, then there are 6 Mars bars left out of 9 chocolates left in the bag. And I didn't pick the boost, so there are 3 boosts left out of 9. So these probabilities are different than what was on the tree diagram for the second stage last time. So similarly, if I pick a boost the first go, then there will still be 7 Mars bars left in the bag, but there'll only be 9 chocolates. There'll only be 2 boosts left. So when you're doing this, make sure that each stage probabilities add to 1. Here, probabilities add to 1, add to 1. So we know we've done something right. So let's now look at this branch here. So let's say I picked a Mars bar first go and then a Mars bar second go. The probability I get a Mars bar the third go, well, there would now be 5 Mars bars left out of 8 chocolates in total. There'd still be the 3 boosts left out of 8 chocolates in total. So for the next one, if I get a Mars bar, then a boost, there will be 6 Mars bars left out of 8 chocolates, and there'll be 2 boosts left out of 8. And that would be the same here. So make sure at each stage, the probabilities add to 1. And for the last one, of course, if you get a boost, then there are 8 chocolates left, 7 of them are Mars bars, and 1 is a boost. Okay, so now I've done something right, because 1/8 plus 7/8 is 1. These 2 add to 1. These 2 add to 1. These 2 add to 1. Great. So the question asked us, what is the probability at least 2 are Mars bars? So let's go and find in this list of outcomes the ones that have at least 2 Mars bars. Well, this one has at least 2 Mars bars. This one has at least 2 Mars bars. This one and this one. So those 4 here have at least 2 Mars bars. So as I mentioned before, know that doesn't mean the probability is 4/8, because each of these is not equally likely. To find the probabilities, we multiply the probabilities for the branches. So the probability of 3 Mars bars in a row is 7/10 times 6/9 times 5/8. So putting that straight in our calculator, we get 7/24. So let's do the same for this one here. Mars bar boost. I go 7/10 times 6/9 times 3/8. So putting that straight on our calculator, we get 7 over 40. Now, if I want to go the next one, MBM, so that is 7 over 10 times 3 over 9 times 6 over 8. But just notice the numbers are the same. On the top, we have a 7, 6, and 3. 7, 6, and 3. On the bottom, a 10, 9, and 8. So these actually have the same probability of occurring. For the last one, I don't need to work anything out. I know it will be 7 over 40 as well. So the probability I get at least two Mars bars. All I need to do is add up all of these probabilities, because I'm really saying what's the probability this or this or this or this happens. And of course, all 4 of those are mutually exclusive. So I just add up their probabilities. So adding all of those up gives us a total answer of 49 over 60, which is about 0.816 recurring. That's our answer. So when we looked at this question with replacement, the answer was 0.784. So it's a little more likely that we'll get at least 2 Mars bars if it's without replacement. That's just because these 3 are a little more likely if it's without replacement. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.